Okay, types of set and set notation, example number 2. So we're going to record the sums that occur when you roll two four-sided dice in an outcome table. Okay, so when I have one four-sided dice, it has sides of 1. I can roll a 2 or a 3 or a 4 for the four sides. With my other four-sided dice, I can also roll a 1, a 2, a 3, and a 4. So we are going to use this outcome table here to record the sums of these two dice, of whatever I roll. So when I roll a 1 and a 1, 1 plus 1 is 2. If I roll a 1 and a 2, the sum is 3. A 1 and a 3, the sum is 4. A 1 and a 4, the sum is 5. Okay, a 2 and a 1 is 3, and then we're just going to keep going here. And so here we have the set of all possible sums that we can roll. So here is our set of numbers that we are going to be dealing with for this example. Next, we're going to display the following sets in one Venn diagram. So we're going to display the sets of rolls that produce a sum that is less than 5 and rolls that produce a sum that is greater than 5. So I'm going to use L for rolls that produce a sum that's less than 5, and I'm going to use G for rolls that produce a sum that is greater than 5. Okay, so these are the two sets that we're going to show on our Venn diagram. So first off, we are going to draw a box. Okay, now the sums that are less than 5, if I take a look here, so the sums that are less than 5 are 2, 3, 4. 5 isn't less than 5. So this less than 5, less than 5, less than 5. So all these results were less than 5. So I have 2, 3, 3, 4, 4, 4. Okay, because we're mathematicians and we like to write things in order, numerically. Okay, so those are my sums that are less than 5. My sums that are greater than 5 are 6, 7, and 8. Okay, so there are no sums that are less than 5 and greater than 5. So these are two disjoint sets. They have no elements in common. So there are no rolls that are greater than 5 and less than 5. So the sums that are less than 5 would be over here. These are our less than ones. And those outcomes were 2. I had 2 3s and 3 4s. Kind of. And our sums that are greater than 5. So these are my sums that are greater, or these 3 6s. Those outcomes where I got those 3 6s, those 2 7s, and the 8. Okay, now in our universal set, so this is a set of all possible outcomes. This is our universal set. And there are some numbers that we do not have in this set and this set that will need to go on the outside. And that is 5. So those 5s still are in our set. We need to have a place for them. So these 1, 2, 3, 4, 5s will go out here. Right. So 5 is not less than 5 and it's not greater than 5. It is 5. So it is outside of these two sets that we have. Okay. And here we now have all of the elements in our universal set U. Okay. So B, we are now going to record the number of elements in each set. So all this N means is number. So this is telling us in mathematical talk that we want to find the number of the elements in set L. So in set L, I have 1, 2, 3, 4, 5, 6 elements. That's all that means, right? Here, I want the number of elements in set G. Okay, so I have 6 in set G as well. In this one, I want the number of elements that are in the complement. So remember that apostrophe means complement of set L. So this means not L. So I want everything that is not in set L. So everything that's not in set L is everything in set G and everything that is out here. So there's 6 here, 7, 8, 9, 10. So there are 10 elements that are not in this set, in set L. So the complement. And the number of elements in the universal set. So how many outcomes did we get? Well, we got 4 by 4. We got 16 full elements, or I can count them in here again as well. And that's it.